Hi everyone. In this video, we'll go through a topic on logarithmic differentiation where we should be able to differentiate by applying logarithms. When do we use logarithmic differentiation? So whenever the function has powers, right? Something like root x, root y, right? Or e to the power x. So whenever there are exponents, we will use logarithmic differentiation. This is just to make it simpler. For example, you have x to the power root x. So what we do here is we'll apply log. So let's say y is equal to x to the power root x. Now what we will do, we'll apply log on both sides. Right? So what will happen? This expression will become log of y is equal to log of x root x. Now, based on the logarithmic property, right? Log property states that if you have log m to the power n, you can write as n into log m. This is logarithmic property. So what we will do here, we will take this power and we'll multiply it like this, root x into log x. So now we have eliminated the power, right? Now we differentiate with respect to x. So what do we get? What is derivative of log y? It's 1 by y and into dy by dx. Let's not forget this, right? Whenever there is y, you need to put dy by dx. And you have root x. Now this is, here you have to apply product rule, right? It's multiplication of two functions. So product rule, what does product rule say? First term into derivative of second term plus second term into derivative of first term, right? So now this is, let's say this is first term, this is second term, right? So I'll take root x into derivative of second term, that is 1 by x, plus second term, which is log x, into derivative of first term, which is root x. Derivative of root x is 1 by 2 root x. So derivative of root x is 1 by 2 root x. Now we'll just find dy by dx. So we'll get dy by dx. We'll shift this y this side. So it will become y into 1 by y will become y by 1. So y into this entire expression. So here I will cancel x. X can be written as root x into root x, right? So I'll cancel 1 root x here and I'll be left with 1 root x. So I'll get y into 1 by root x plus log x by 2 root x. This is nothing but dy by dx. Now let's simplify this further. So it will become, I'll take LCM. LCM will be 2 root x, right? Between these two, LCM would be 2 root x. So I will have to multiply this with 2, right? Only then I will get 2 root x. But I have to multiply numerator. So I'll get 2 plus here I have to multiply with 1 to get 2 root x. So I multiply numerator. So I get log x. So basically dy by dx is equal to y into 2 plus log x by 2 root x. Let's take another example where we have to differentiate this entire function, right? Now we'll call this as y. So here you see there are powers, right? There are powers here. So we'll apply log on both sides, right? So we'll apply log on both sides. To simplify, what we'll do, we'll take this as one function and this as one function. That is, we'll call this as u plus v is equal to y. What is u? U would be this function, x to the power log x. This is u, and v will say is log x to the power x, right? We'll write the function like this. Now we'll separately differentiate and apply log, right? So we'll take first function u is equal to x to the power log x, right? And then we'll do the same for v. So now what we'll do, we'll apply log, right? So it will be log u is equal to, it will be log of x to the power log x. Now using log property, log m to the power n. So what will happen? This will come here, right? So it will become multiplication. Log x into log x is log u. Now I'll differentiate with respect to x. So I will get what is log u? 1 by u. And I have to put du by dx, right? Because it's not x here, right? So that's why we'll have to put du by dx is equal to log x into log x. So now we'll apply product rule here, right? There are two functions. So I'll take first function log x into derivative of second function, which is 1 by x, plus second function, which is again log x, into derivative of first function, which is 1 by x, right? So now what do I get? I'll get 1 by u into du by dx is equal to, this is happening 2 times here, so it will be 2 log x by x. Now I'll just find du by dx. What is du by x? Dx, just shift this here. So it will be u into 2 log x by x. So this is du by dx. Similarly, we'll do for this function also. V is equal to log x to the power x, right? So I'll apply log. So I'll get log v is equal to log of log x to the power x. Now using logarithmic property, what will happen? X will come here. So it will become x into log of log x. This is equal to log v. Now I'll differentiate. With respect to x. So what do I get? I'll get 1 by v, derivative of log v is 1 by v, into dv by dx. Because I'm differentiating with respect to x. This is not x here. We have v. So it's dv by dx is equal to, now here we'll apply product rule. So it will be first term x into derivative of second term. That is derivative of second term, which is log of log x, plus second term, which is log of log x, into derivative of first term, which is x. So this will be 1 by v dv by dx is equal to, what is derivative of log x? We'll have to apply chain rule. X into derivative would be 1 by log x, and again derivative of log x is 1 by x. So this x and this x will get cancelled. So we'll get log of log x, derivative of x is 1, right? So this is nothing but 1 by v into dv by dx is equal to 1 by log x plus log of log x. Now I just want dv by dx. Let me shift v this side. So it will become dv by dx is equal to v into 1 by log x plus log of log x, right? So now we found the derivatives of u and v. Now what is y? Y is u plus v. So if I differentiate now with respect to x, what will it be? It will be dy by dx is equal to du by dx plus dv by dx, right? And now we'll substitute. What is du by dx? It is nothing but u into 2 log x by x plus v into 1 by log x plus log of log x, this one, right? This is dy by dx. Now I'll substitute u and v here. What is u? U is x to the power log x. This is u and this is v, right? We'll substitute. U is x to the power log x into 2 log x by x. V is equal to log x to the power x, log x to the power x into 1 by log x plus log of log x. Now we'll take another example, right? We'll differentiate this entire function with respect to x. So what we'll do, first we'll assume let y is equal to root of x minus 1 into x minus 2 by. So now we'll apply log, right? Why? Because there is square root. What is square root? We can write this as in this form. We can write this as we can write this as to the power half, right? Square root is nothing but half, right? So now we have power here, so we'll use log. So we'll apply log. So we'll get log y is equal to log. So this is what we get. Now we'll use the logarithmic property. Log m to the power n is n log m. So this will be half into log of x minus 1 into x minus 2 divided by x minus 3 into x minus 4 into x minus 5. This is log y. Now what we will do, this is, if you observe, we'll have to remember the other logarithmic properties. What are those? Log of a by b can be written as log of a minus log of b. And log of a into b can be written as log of a plus log of b. Right? Now we'll have to use both these properties because you have division here and you have multiplication. So we'll first solve the division. This is this by this. So log of this minus this. You can write this as log of x minus 1 into x minus 2 minus log of denominator x minus 3, x minus 4 into x minus 5. Now again, you have multiplication here, right? So you can use the addition logarithmic law. That is, you can write it as, let's not forget, this half is for the entire expression. So half into, I can write this as log of x minus 1 plus log of x minus 2. When you have product and when you apply log, you can write it in the form of addition. Now minus, similarly here also, right? It will be log of x minus 3 plus log of x minus 4 plus log of x minus 5. Let me put this bracket, right? This half is there for this one also. This is nothing but log y. Now I'll differentiate, right? I'll differentiate with respect to x. What do I get? What is derivative of this? It will be 1 by y into dy by dx equal to half log of x minus 1. What is derivative of log of x minus 1? 1 by x minus 1. Then what is derivative of x? It's 1. Plus, again, this is 1 by x minus 2. Derivative of this. Derivative of x is 1 into 1. Right? Minus log of x minus 3 is 1 by x minus 3. Log of x minus 4 is 1 by x minus 4. Log of x minus 5 is 1 by x minus 5. Right? And this half is for the entire expression. So what do I get? Half into 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus into plus is minus 1 by x minus 4 minus 1 by x minus 5. Right? So this is 1 by y into dy by dx. So now I'll shift this y here so that I get dy by dx alone. So dy by dx is equal to y into half, that is y by 2, and I'll write copy the entire thing. And y is nothing but, what is y? Y is equal to this entire thing, right? We'll have to write this, where y is equal to this entire expression, right? Instead of y, we have this expression. So this is the derivative. So with this, we have come to the end of this particular topic. If you found this video useful, do press a like and share it. Thank you.